Howdy, 8th graders. Your section that we're going to cover tomorrow is going to be section 1.6 out of the book, and it is covering the converse of the Pythagorean theorem. And I know you're already asking yourself, what in the world is that? Don't worry, I'll explain it all. It'll be just fine. The triangle inequality theorem is the first one we need to understand to be able to do this. And that just says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so adding the lengths of two sides together will be greater than the third side alone. So for an example, do these sides make a triangle? Well, let's see. If I have sides of a triangle that are 7, 9, and 12, it says the sum of the lengths of any two sides. So if I add any two sides together, is it going to be greater than the third side? Is 7 plus 9 greater than 12? Yes. Is 7 plus 12 greater than 9? Yes, it is. And the two that I have left are 9 and 12. When you add 9 and 12 together, would it be greater than 7? And yes, it would be greater. So that one is yes, it works. Okay, that one worked. So let's try another one. What if I have 6, 7, and 15 for my sides? So if I add 6 and 7 together, ooh, 15 is greater. So you know already that it doesn't work. But if you add 6 and 15, that is greater. And if you add 7 and 15, that is also greater. But this one right here is not greater, so it does not work. That is what this means. Triangle inequality theorem. All three sides, it has to work. No matter which two sides you add together, they have to be greater than the third side, otherwise it will not make a triangle. Okay, then the other one we're going to do today is the converse of the Pythagorean theorem. And we've actually done this before. We just have not called it this, but this is the technical term for it. If the equation a squared plus b squared equals c squared, and that is the Pythagorean theorem that we've been covering the last few days, if that equation is true for the lengths of the sides of a triangle, that triangle is a right triangle. Well, that would make sense, right? Because that's what we've been doing this whole time. Remember that the Pythagorean theorem only works for a right triangle, so that would make sense. Okay, we just haven't called it this. So if I have a triangle that has sides that are 3 centimeters, 4 centimeters, and 5 centimeters, will that make a right triangle? Well, if the a squared, b squared, c squared is true, then yes, it will. So the Pythagorean theorem is a squared plus b squared equals c squared. And we're just going to assume they already have them in order, a, b, c. So you're going to plug them in. 3 squared plus 4 squared equals 5 squared. And then just go ahead and do the math. 3 squared is 9, 4 squared is 16, and 5 squared is 25. And this side, 9 plus 16 is 25. So does 25 equal 25? Yes, it worked. So a triangle with these three sides would have to be a right triangle because this theorem works. We just proved the theorem again, just like we've been doing the last couple days with our labs that we've been doing. So bring that knowledge with you, and we will discuss it even further. See you later.